Now I'll be talking about simultaneous equations, and this is something that you should have come across before. So what are simultaneous equations? These are equations involving two or more unknowns that are to have the same values in each equations. Well, what do we mean by this? For example, if you are given two equations, say x plus y is equals to 5 and x minus 2y is equals to 3. Now these are two equations in which we have two unknowns. X and y are both unknowns in this equation, and we are looking for the values of x and y that will satisfy both this condition and this condition. So when you have equations in these regards, they are referred to as simultaneous equation. And you should know that to solve a simultaneous equation, the number of independent equations must equal the number of unknowns. So in this case now, we have just two unknowns, x and y. So we need two independent equations to solve it. So we need at least two independent equations. So what do we mean by independent equation? For example, if I multiply this first term here by 2, say 2, I'm left with what? 2x plus 5 plus 2y is equals to 10. Even though this equation looks different from this equation, they are both the same thing because I can reduce this to this. So in this case, these two equations are not independent, they are dependent. So independent means that they stand alone. So something like this are independent equations. So I need two independent equations to solve equation with two unknowns. So let's say I have, for example, x plus y plus z is equals to 10, and I have three unknowns. So I need I need three equations to solve it. So if I do this now and I have 12, this is 2z, so I need at least three equations, and the third equation can just be x plus y is equals to 15. So I need at least three independent equations to solve equations with three unknowns. But luckily for us, for JAMB, we'll just be focusing our attention to just equations with two unknowns, and let's try to solve some examples. So first, we'll talk about the elimination method. There are two major methods of solving simultaneous equations. We have the elimination method and the substitution. So in elimination method, we try to make one variable in both equations equal so that we can subtract the two equations to eliminate that. So this is a mistake here, to eliminate that variable. That is what is meant to be here, to eliminate that variable or that term, more appropriate to use. So now let's start out by trying to solve this with elimination method. So let's say, for example, if I want to eliminate variable y now from these two equations, what would I do? So first, this is my first equation and this is my second equation. So what would you do? You look at the coefficient of y in the second equation. And what is the coefficient of y in the second equation? Coefficient of y is -2. So you multiply the first equation by the coefficient of y in the second equation. So you multiply the first equation by the coefficient, which is what? -2. Similarly, you multiply equation 2 by the coefficient of y in equation 1. And what is the coefficient of y in equation 1? 5. So I multiply this by 5. So when I expand, I multiply everything here by -2. So -2 times 2x will give me what? -4x. -2 times 5y will give me what? -10y is equals to, and here I have what? -2. Same thing, multiply 5 by 3x, I have what? 15x. Then 5 times -2y gives me what? I have -10y. And finally 5 times 30 gives me what? 30. So what can I do now? Now I can subtract both equations. So when I subtract equation 2 from 1, so I have -14 minus 15x, that is -14 minus 15, which gives me -19x. So now I have -10y minus -10y, which is -10y plus 10y, which gives me 0. So I've eliminated this term of the variable y. So I'm left with is equals to, sorry, 5 times 30 is 150. So this is a mistake here. So I'm left with what? -2 minus 150. So -2 minus 150 will give me what? -152. So all I have to do is to divide both sides by minus 19. And what am I left with? I'm left with what? My x being equals to what? 8. So now that I've gotten my x being equals to 8, I can substitute the value of x in any of these two equations to get the value of y. So here we'll try to use the first equation. So the first equation, I'm told that 2x plus 5y is equals to 1. So I just substitute 8 for x plus 5y is equals to 1. So I have 16 plus 5y is equals to 1. So I have 5y is equals to 1 minus 16, which is equals to minus 15. And I can divide both sides by 5. So I'm left with what? Y is equals to minus 3. So now we have x is equals to 8 and we have what? Y is equals to minus 3. So to recall, when we are trying to do with elimination method, what we are trying to do is we are trying to remove one of the variables, and we do that by multiplying the coefficient of that variable in the second equation by the first equation, and we'll do likewise for the second equation. So now let's move on to the second method of solving simultaneous equation, which is the substitution method, and this is a fairly straightforward approach. So what are we trying to do? We make one variable the subject of formula in one equation, and we substitute its value into the second equation. So for example, let's take this first equation now and we'll make one of the variables the subject of the formula. So let's try to make x the subject of formula in this equation, in equation 1. So we'll make x subject of formula, make x subject of formula in equation 1. So what are we left with? We have 2x plus 5y is equals to 1. So I have 2x is equals to 1 minus 5y. So I have x is equals to 1 minus 5y over 2. So what do we do now? We now substitute x is equals to 1 minus 5y over 2 in equation 2. So I substitute that value in equation 2. And when I do that, what do I get? I have what? So I have 3 into bracket 1 minus 5y over 2, then minus 2y to be equals to 30. So I can easily expand. So I have 3 over 2 minus 15. 3 times 5 is 15, minus 15 over 2y, then minus 2y is equals to 30. I'll write it in decimal to make calculation easier. So 1.5 minus 7.5y minus 2y is equals to 30. So when I collect like times, I have minus 9.5y is equals to 30 minus 1.5, which is equals to 28.5. So my y now will be equals to what? 28.5 divided by minus 9.5, and that gives me my y value to be equals to what? Minus 3. So I've already written x in terms of y, so I can find the value of x. So I said x is equals to 1 minus 5y over 2. So that just be equals to 1 minus 5. And what is my y? Minus 3 over 2. So that will be 1. What is minus 5 times minus 3 plus 15 over 2? And that just be what? 16 over 2, which gives me 8. So again, I get x as being equals to 8 and y as being equals to minus 3. So that is how to make use of the substitution method. But now let's look at more complicated quadratic equation. So now, more complicated simultaneous equation. So now consider the simultaneous equation in which you have one linear and one quadratic term. So I should mention that what we have been writing before are just linear equation, because the highest power that we have there are just power of 1. But now we're going to be examining quadratic terms now. So here one of the equation is linear while the second is quadratic. In this case, we expect two sets of solution, and we'll come to see what I mean by that. So let's try to tackle this example now. So this example, we are told that 3x plus y is equals to 10. in my first equation, I was told that 2x squared plus y is equals to 19. My second equation. So let's get started. So first, what I'm going to do, I should mention that in this case, basically, we are just going to be making use of the substitution method. The elimination method does not work when I'm trying to solve problem of this regard. So first, I'll try to write one variable in terms of the other and substitute it in my second equation. So now I'll try to make y subject of formula in equation 1. So I want to make y subject of formula in equation 1. And what does that give me? I have 3x plus y is equals to 10. So therefore y is equals to what? 10 minus 3x. So now I can now substitute y is equals to 10 minus 3x in equation 2. And let's do that. So we have what? 2x squared plus my y becomes 10 minus 3x then squared is equals to 19. So now I'm trying to find this quantity squared. So how do I do that? I'm going to just take a brief detour now to explain how you expand something like this. So there are two ways to go about it, and basically this is a simple approach. Or what you do normally is you write out those terms 2 times and try to multiply it. So you have something like this. So you expand 10 times 10, you have 100. 10 times this, you have minus 30x. You have minus 30x, and you have minus 3x minus 3x, so give me minus 9x squared. So that is the same thing as what? 100 minus 60x plus 9x squared. So that is what it will become. But I'm going to show you a shortcut to go about finding the square of a number. So what you do basically is you say the first term squared. So what is 10 squared? 10 squared is 100. Then you multiply all terms and the power. So you say 10 times minus 3 times 2. 10 times minus 3 is minus 30. Minus 30 times 2 is minus 60. So 10 times minus 3x times 2 give me what? Minus 60x. And you find the square of the second term. So minus 3x squared will give me what? Plus 9x squared. So you can just do that directly instead of trying to expand. So you can practice it with other examples to see how it works. So now you collect your like times. So you have 2x squared plus 9x squared, which gives you 11x squared. Then you have minus 60x. Then you have 100. When you bring the 19 to this side, you have 100 minus 19, which gives me what? Plus 81 is equals to 0. So now I solve this normally with the use of my simultaneous knowledge of my solving of my quadratic equations. When I multiply these two terms, I have 891x squared. So what two numbers would I multiply together to get this? In which when I add them, I'll get minus 60x. So what are those numbers? If you check carefully, you see that they are minus 33x and minus 27x. So I can substitute it here. And what does that become? That becomes 11x squared minus 33x minus 27x plus 81 is equals to 0. So 11x is common here, and what am I left with? I'm left with x minus 3. And in the next case, I have minus 27 minus 27 is common, and I have similarly x minus 3 being equals to 0. So I pick one of these, I have x minus 3, and I have the other, which is what? 11x minus 27. So let's go back down now to the next page. So now continue. So what are the factors that we've gotten? We've gotten what? X minus 3 and 11x minus 27. So what do we do now? We'll try to find the value of x. So we know that equals to 0. So we have x minus 3 is equals to 0, or 11x minus 27 is equals to 0. So here we know that x is equals to 3, and in second case we know that 11x is equals to 27, and we can divide both sides by 11, and we have what? X is equals to 27 over 11. So now there are two answers. First, x is equals to 3, and x is equals to 27/11. So now we have to find the value of y. So now recall that we said previously when we were trying to substitute that y is equals to 10 minus 3x. So now there will be two values of y similarly because we have two values of x. So first, what is y? What is y when x is equals to 3? So what would that become? So we just put y is equals to 10, and in this case x is 3. So what is our value of y? 10 minus 9, and that is equals to y 1. So when x is equals to 3, y value is equals to 1. And in the second condition, what is y when x is equals to 27/11? So we do that the same way. So we just have y is equals to 10 minus 3 into bracket 27/11, and that is equals to what? 10 minus 81/11. The LCM here is 11. I have 110 minus 81. I am left with what? 110 minus 21 is what? You have 29/11. So you have two answers. So the first answer you have is when x is equals to 3, y is equals to 1, and the second set of solution is when x is equals to 27/11, my y value is equals to 29/11. So that is what we mean when we say that when you solve a simultaneous equation in which one is quadratic, you get two sets of answers. So as you can see, these are our first set of answer and these are second set of answer. So any of these sets that you substitute into the original equation, you find out that they satisfy that equation. Now let's solve one more example to give you, and this will be the final example to give you further idea of what we're talking about. So here now we have 3x plus 4y is equals to 11 and xy is equals to 2. So now we can see that we have two terms, xy. So this xy term is what makes this quadratic. So now I'm going to try to make y the subject of formula in equation 2. So make y the subject of formula in equation 2. So what does that become? So I have xy is equals to 2. So if I divide both sides by x, what does that result in? I have y is equals to 2/x. So I can now what? This is equation 1 and this is equation 2. I can now substitute y is equals to 2/x in equation 1. And what does that become? So I have 3x plus 4 into bracket 2/x is equals to 11. 2/x, sorry. So what does that become? I have 3x plus 4 times 2 is what? 8/x is equals to 11. So what can I do to remove the x bottom? I can multiply both sides through by what? X. So I can multiply here by x and I can multiply here by x. So when I do that, I have x times 3x, which gives me 3x squared, and I have x times 8/x, which cancels out. So I'm left with what? 8, which is equals to 11x. Then I bring it down here. I have 3x squared minus 11x plus 8 is equals to 0. And if you see, this is a quadratic equation that I have to solve. And how have you been going about this? So you multiply these two terms, and when you do that, you have 24x squared. Then you ask yourself, what two numbers can I multiply together that such that I'll get this, and when I add them I'll get minus 11. So that is just what? Minus 3x and minus 8x. Minus 3x times minus 8x will give me 24x squared, while minus 3x minus 8x will give me minus 11. So I substitute minus 11x for these two terms here. So I have 3x squared, then I have minus 3x minus 8x plus 8 is equals to 0. So I collect factorize now. So I have x, 3x is common to both of them, and I'm left with what? X minus 1. And the same thing here, minus 8 is common here, and I'm left with what? X minus 1 similarly. So the factors, I just pick one, which is what? X minus 1 and what? 3x minus 8. So let's move on to the next page. So let's write that out again. To have what? We have x minus 1 and what? And 3x minus 8 here being equals to 0. So we can write that as x minus 1 equals to 0 and what? 3x minus 8 is equals to 0. So here we have x is equals to 1, or we have 3x is equals to 8. If it's variable side by 3, we have what? X is equals to what? 8 over 3. So as you can see, we have two values for x which are 1 and 8 over 3. So now to find the value of y, we've defined y as what? 2 over x. So we ask ourselves the first question that what is y when x is equals to 1? So when x is equals to 1, my y will just be 2 over 1, and that is equals to what? 2. So now we ask ourselves again that what is y when x is equals to 8 over 3? And what would that be? My y will just be what? 2 over 8 over 3, which is same as writing 2 divided by 8 over 3, which is same as writing 2 times 3 over 8. 2 here 1, 2 here 4, and that is equals to what? 3 over 4. So we have two sets of solution. So when x is equals to 1, my y is equals to 2, and when x is equals to 8 over 3, my y is equals to 3 over 4. So this pretty much sums up all you need to know with regards to simultaneous equation with one linear and one quadratic.